Hey, welcome to the IT office. In the last video, we talked about VLANs and how they work. In this video, we're going to focus on three things: access, trunk, and native VLAN, okay? So, let's remember a few concepts from the previous video. So, first of all, access ports are ports that are not doing any tagging. So, in this case, we're going to configure switch 1 and we're going to configure port gigabit 03 and port gigabit 02 as access. So remember, access, send or expect traffic untagged, okay? No tag is added from the computer or to the traffic sent to the computer, And we have the trunk port, which is the port that will carry traffic from multiple VLANs. In this case, gigabit 00 is going to be a trunk port because this, let's say this highway is going to pass traffic from VLAN 10 and VLAN 20 devices. So it will add the tag. So this port is doing tagging and it will send and receive traffic using those two tags, in this case 10 and 20. Okay, so let's take a look at switch 1. That's the one we are configuring today. So initially there is no VLAN. You can run the command show VLANs. There is no VLAN. We can see everything in the default VLAN 1, which is practice in the industry for most of the switches, for most of the vendors, that every port comes in the VLAN 1. So you can plug any device and the port will be in that default VLAN. Okay, so now we need to create the VLAN. We can use the command VLAN and then the ID. We use the command name. We can assign a name for the VLAN, in this case VLAN 10 name blue, and then VLAN 20 name green. Okay, we do show VLAN again. We see the two VLANs created. We don't have any ports assigned to the VLAN. Now we need to assign the ports to the VLAN. So interface gigabit 03, okay, switch port mode access. There are some dynamic port configuration in Cisco, but I'm not going to discuss that on this video. We are going to focus on access and trunk modes, okay? So access is to send and receive traffic untagged in the VLAN that we are going to associate. In this case, for gigabit 03, which is connecting Windows through, we need to assign switch port access VLAN 20. Okay, and for the port interface gigabit 02, we change the mode to access, switch port access VLAN 10. Okay, and then interface gigabit, this is the trunk port, switch port trunk encapsulation. Cisco had these old modes, which is ISL. And ISL is a Cisco proprietary trunking protocol. In this case, we're going to use .1Q because that's the standard. And if you're connecting the switch to another non-Cisco device, that's the mode you should use, okay? So .1Q, then switch port trunk, switch port mode trunk, okay? So now let's take a look. Okay, I forgot to bring up the port, so let's do it. Let's shoot, no shoot, to bring them up. Okay. We do a show interface status, which is another command that helps us validate these configurations. So gigabit 00 is in trunk mode. Oh, gigabit 03 is in trunk mode. I did that by mistake. Oh, I'm sorry. Gigabit 03 should be in VLAN 20. For some reason I configured as a trunk, but let's do this. Let's default interface gigabit 03 Let's interface gigabit. That will revert every configuration to the defaults. Interface gigabit 03 mode access and access VLAN 20. VLAN 20. Let's do a shoot, no shoot. Let's see now. Status. Okay, so useful commands show interface status is a very useful command. It will display all the status of the port. It will include the, let's say, if the port is connected or not connected, if it's disabled or not, which is really useful for troubleshooting. In this column VLAN, if the port is trunk, it will display trunk. That means that port support multiple VLAN. It will show also the VLAN assigned to each port in the access mode, okay? So another command we can use to validate is show VLAN. In this case, we can see the two ports in the VLAN, that is VLAN 10 gigabit 02, VLAN 20 gigabit 03. That's very helpful. Now this other command show interface trunk. Sorry. So in this case, let's think about this a little bit. So the port is gigabit 00. The VLANs allowed in the trunk is from 1 to 4094. That's because by default, when you set up port in trunk mode, all the VLANs are allowed, or the existing VLANs in the switch are allowed. So all the VLANs are active and all the VLANs are passing through this port. Now, it's important to understand that you can limit the VLAN passing through a port. That could be a network requirement because you don't want the traffic propagation of a specific VLANs to a port because of security reasons, or maybe it's not needed. So we can, let's say, manually assign which VLANs can pass through that port. Let's do this in this example. Switch port trunk allow VLAN at, we need to specify them in this case, so 10 and 20. So let's see, show run interface gigabit 00, show interface trunk. Let's see. Okay, this is doing negotiation. I don't know why I think we made a mistake before. I configured the trunk encapsulation in the gigabit 03 and not on the gigabit 00. So doing negotiation, but I won't talk about dynamic modes in this video. We can see that later. We are going to do it static. So let's switch port trunk encapsulation.1q switch port mode trunk. Okay, show interface trunk. Let's see. Now it's not, you see this n-802.1q, that's means negotiated. Okay, in this case it's on, it means static. Okay, because access and trunk are static modes, because Cisco supports something called DTP, which is negotiation of the mode of the port. Okay, but we're going to do it static. So now we see that the allowed VLAN are only 10 and 20. That's another command to validate, so we can check each individual port and the configuration. So for example, 02, 03 and 00. So static mode access and access VLAN 10, static mode access and access VLAN 20, and static mode, well, encapsulation.1q, which is the standard 802.1q, is the standard tagging protocol, and the mode is trunk, and we are going to allow only these two VLANs. Okay, so far so good. We are going to see now the show VLAN command again. You can see everything here. Now you won't see ports assigned to trunk mode here in this list. That's why you don't see gigabit 00 here. And we can show interface status. You see the trunk, you see the other two ports. Okay, another command that you need to keep in mind 03 switch port. Okay, so this command will show the configuration of the port regarding trunk access modes of the ports. Okay, so in this case the port is switch port. It means that it's acting as a layer 2 port. Remember, I will explain you later that there are layer 3 or layer 2 switches. Okay, when you have a layer 3 switch, you can change the port mode to support layer 3 traffic, meaning that you can assign IP address to the port, but I will explain you that later. For layer 2, in this case we're using this switch as layer 2 only. The switch port must be enabled, so keep that in mind because that's an important troubleshooting consideration. Okay, administrative mode, I mentioned that we are doing static mode, in this case static access, and operational mode is static access. Trunking or output is not relevant in access mode, and then access VLAN 20. Everything else is not relevant since it's regarding private VLANs or trunking. So what you need to see is the mode, right? And depending on the mode, you check the static, the access or trunking parameters. In this case, everything regarding access is relevant to us because the port is in a static access mode. If we check the trunk port, we are going to see that the output is different. Okay, so administrative mode is trunk, operational mode is trunk, encapsulation.1Q, not ISL. ISL is a legacy encapsulation supported by all Cisco devices. We don't use that anymore. That's not the standard, so that shouldn't be relevant on these on newer implementations. Okay, let's see what else is relevant here. Trunking native mode VLAN. So in this case, the native VLAN is 1, but I will explain you that in a few seconds. Okay, trunking VLANs enabled 10 and 20. Okay, so let's take a look at the native VLAN. Let's see if you see the configuration of this port. Show run interface gigabit 00. I will let you know what the native VLAN is. So let's see, in this switch to device, show run interface gigabit 00. Let's add the pruning, or let's limit the VLANs to allow only VLAN 10 and 20. If you see here, you will see that everything is allowed. If we create a new VLAN, it will be allowed in the trunk. But let's limit to 10 and 20 in this example. Interface gigabit 00. You know, it's a good practice just to allow what you need in the ports. Okay, so now if we send traffic through the trunk port, all the tags are going to be added to the frame when the traffic passes. For example, when we send traffic from Windows 2 to Windows 4, we're going to see the tag. And when we pass traffic from Windows 3 to Windows 1 or Kali 1, we're going to see the tag from VLAN 10 and 20. But there is something called the native VLAN. The native VLAN basically is the VLAN that won't have any tags in the trunk, right? In this case, the native VLAN is VLAN 1. So that means that if we had another device, right, like a computer here and a computer here, in that VLAN 1, right, VLAN 1, and if we send traffic across the trunk port, this frame won't have any tag. Okay, if we send traffic from Windows 2 to Windows 4, we will see the tag in the frame, okay, for the VLAN, in this case 20. Okay, Same for traffic coming from Windows 3 to Windows 1, we are going to add the tag for VLAN 10, okay? But for the native VLAN, there is no tagging, okay? That's by default, okay? We can change the VLAN, the native VLAN in the trunk for a non-existing VLAN or something else different from the default VLAN, okay? Because the most secure way to do it is assign a new VLAN to use it as native VLAN, or there are some switches that allow us to remove the native VLAN from the trunk. But let's see how the tag works. If we make a quick packet capture and we do a few pings, we can see that tagging works, and we are going to change the native VLAN to VLAN 10, for example, and I'm going to show you how the tags work in that case, okay? So let's see, let me remove from this any CDP or TCP or ARP. Let's see, maybe with AND. You can remove everything, yeah. Okay, let's do a ping from Windows 1 to Windows 3, okay, which are in VLAN 10. Then that, let's see the IP config, I don't remember the IP. Okay, it's in the diagram 10.10.15.33. Okay, let's see if the traffic is passing through. Okay, ARP-A. We don't have connectivity yet. Let's take a look at the VLAN configuration in switch 2. Show interface status. So, we need to configure the VLANs here. We don't have the ports assigned. Okay, that's okay. Let's do interface giga 10. This is for Windows 4, which is in VLAN 20. Switchport mode access, switchport access VLAN 20. Okay, and then from Windows 1 and Kali 1, we can do the same. Interface range, switchport mode access, port access VLAN 10. Okay, let's take a look. Show interface status. Let's see now the ping. Okay, still not working. The ports are up, and let's see the MAC address table to see if we see the MAC address table populating. Show interface status. Okay, VLAN 10, gigabit 02, gigabit 03. Show. Let's see, let me run this ping for. Okay, now it's good. Okay, I think it was maybe spanning tree or something. Working there regarding the learning process of a spanning tree, but we're going to see that in a later video. So you see this ID, this corresponds to the VLAN tag 802.1q. VLAN 10 traffic is tagged across the ports gigabit 00 of switch 1 to gigabit 00 of switch 2. Okay, so now if we do a ping from this device, which is Windows 2, we are going to ping Windows 4, 10, 20, 15, the 44. Okay, now we should see traffic. We should see traffic VLAN ID 20. Okay, that's so far. This is good. We can see traffic from both VLANs being tagged across the connection. Okay, But now let's switch that native VLAN to VLAN 1. So show interface gigabit to VLAN 10, sorry, VLAN 10 switch port. So let's see, show room interface gigabit 00. Let's do interface gigabit 00, switch port trunk native VLAN. Now we need to assign the VLAN, VLAN 10, show room interface gigabit 00. Okay, now you see the output here, because by default it's VLAN 1, it won't be displaying the output of the command, but now it's VLAN 10. And if we run show interface gigabit 00 switch port, now we see here in trunking native mode VLAN 10, it's VLAN 10, okay? But let's try a ping and let's see what happens. Now we are trying to ping from Windows 1, which is connected to port gigabit 02 on switch 2, the topology, and we change the tagging in switch 1, but we didn't do the tagging on switch 2. Okay, so we are seeing the incoming traffic from switch 1, right? And that traffic is going through, let's see. Let me show you what we did. We used the native VLAN here 10, and what happening is that we didn't do the change here. So here the traffic is being tagged using VLAN 10. If you see, this is the tag of this frame, send it here, and then we add the tag of the ICMP traffic. Here is VLAN 10, right? This switch 1 receives the traffic, but it's expecting that traffic, it will be sent back, but using no tag, because here the native VLAN is 10. So we have a mismatch in the native VLAN, okay? So now if you see the switch, it generated this alert that there is a mismatch in the native VLAN, okay? So we have VLAN 10 as native here in this switch, okay? But the native VLAN here is different, so let's take a look. Let's run show interface gigabit 00 switch port. You see, we didn't do the change on this side, so we need to do it so it works properly, right? Because if we do tagging one direction, we need to do tagging in the other direction, otherwise it won't make sense, right? So VLAN 10. Now I change it. Now VLAN 10 is the native VLAN. Before was VLAN 1, which is the default. Now it's VLAN 10. Now let's see. Now we see the request and the response, and we don't see any tagging, okay? Because we decided in this design that VLAN 10 was the native VLAN, and the native VLAN traffic is untagged, okay? So keep that in mind. To recap, trunks will tag the traffic, okay, for all the VLANs except the native VLAN. By default, the native VLAN is VLAN 1, but you can assign anything else. We can limit the VLANs traffic that we send across any trunk port. We can limit it because it's a security measure. Probably you don't need to propagate all the VLANs to all the ports that you are using as trunk. Remember, trunk is a Cisco term. The standard term is tagging, okay, or tag port. So keep that in mind, because in some other devices trunking means something else like LACP or other protocols. But keep in mind that the concept is 802.1q tagging protocol, okay? And access ports are ports assigned to a specific VLAN. in the meaning that they are associated to the VLAN, but they don't do or expect tag traffic. Okay, for example, ports that you use to connect computers, printers, cameras, and so on and so forth. Okay, and the native VLAN is the VLAN that won't be tagged in a trunk port. For example, in this case, gigabit 00 used by default native VLAN 1, meaning that VLAN 1 traffic was not tagged, but then we switch that to VLAN 10, meaning that VLAN 10 traffic wasn't being tagged. Okay, so those three concepts are very, very important for layer 2 switching and for layer 2 design. So I hope you have enjoyed this video. Don't forget to subscribe, like, and see you in the next one.